Hello students, in this session let us discuss how Windrose diagram of type 2 will be constructed to determine the best runway orientation. So now let us revise once. We have two types of Windrose diagram of type 1 and Windrose diagram of type 2. So now, as we discussed in the previous session, Windrose diagram of type 1, the radial lines indicates the direction of the wind, whereas the concentric circles represent the wind duration. So here in the type 1, we can only consider the two parameters, wind direction and the wind duration, or sometimes we can also consider the wind intensity or velocity of the wind can be considered. But here when we constitute the Windrose diagram of the type 2, we can represent all three parameters of wind data like wind speed, wind duration and wind direction. All the three parameters can be considered in case of type 2 Windrose diagram. So in the representation in the type 2 Windrose diagram indicates, so the radial lines similar to how we had in the Windrose diagram of type 1, all these radial line indicates the direction of the wind speeds, and the concentric circles what we have drawn previously in the Windrose diagram of type 1, that was representing the wind duration. But here the concentric circle represents the wind speed. The concentric circle represents the wind speed. And also the region what we have here in between the radial line and the concentric circles, that will represents the wind duration. So that means that we have so many number of sectors within this circle which are in between the radial lines and concentric circle, and these sectors represents the duration of wind. So let us see clearly. So now here this is a typical Windrose diagram of type 2. So you can see here the various directions are there. So now from the north direction, I'll just read out the one wind data from one particular direction. From the north direction, we have the wind of intensity 6 to 25 kmph for a duration of 7.4% in a year. Similarly, the wind which is having an intensity of 25 to 40 kmph is having a duration of 2.7%, and the wind of intensity 60 to 65 kmph, the duration is 0.2. So now from the north direction, total intensity will be 10.3. When we constitute the Windrose diagram of type 1, we had only considered this total. We have not considered what is the intensity of the wind in each direction. But when the type 2 Windrose diagram is constituted, we will consider the direction will be considered, intensity will be considered, as well as the duration of wind is considered when we draw the Windrose diagram of type 2. So now here this circle here, the picture here represents the Windrose diagram of type 2. So now you can see all these radial lines indicates the direction which is as similar to the type 1, and the concentric circles which are in red, green, blue and black, so this will represents the intensity or speed of the wind. So for example, red line indicate intensity of 6 kmph, green intensity of 25 kmph, the next line intensity of 40, and here intensity of the 65 kmph. Please note that here when we draw the concentric circle, it has to be drawn to some scales. Okay, so maybe here only those intensities which we are having in the data, only those lines are highlighted here. Yeah? And also the calm period, we know that it is a 13.5 percentage. So it is similar to how we calculated in the wind force diagram of type 1, because the total intensity here will be 86.5 percentage somewhere. So when we compute the calm period, 100 minus 86.5, that will be 13.5 percentage. Now how to draw with the go with the Windrose diagram of type 1. So first the radial lines are ready, and we have also drawn the concentric circles which will represent the intensity of the wind. The next is we have to mark the wind intensity. So now for example, I take from the north direction for a speed in between to 66 to 2.5, the wind duration is 7.4. So now you check here, I have it the north direction, the wind duration in between to 6 to 6.5. Here I have the 6 is the red line, and 6 to 25 is 25 blue line. So that 7.4 value I'll write in the sector, in the particular sector which is in between to 6 to 6.5. The next is in between 25 to 40 kmph, the duration is 2.7. So in between 12, it is a 25 line, 40 line, in between 20 to 20.5, in between 25 to 40, I'll write the duration of 2.7. Similarly, 40 to 65 kmph wind intensity is represented in the third sector. So likewise, the wind duration has to be written in the all the sectors considering the intensities as given in the data. Clear? The next is, once this diagram is ready, we have to determine the best runway orientation. So now you can see here we don't have to connect any points here. So how to determine the intensity? So now to determine the runway orientation, so what we have to do is we should have one rectangular transparent strip. Okay, so that what should be the, we will have the rectangular transparent strip. So what should be the length and width of the transparent strip? So here the length of the rectangular transparent strip has to be taken in such a way that that will be more than the watt scale we have considered here to draw the Windrose diagram. Okay, so you check what is the diameter of this circle. So the length of the transparent strip should be little more than the maximum diameter that is considered when we drawn the Windrose diagram. Clear? And the next one is the width of the rectangular strip must be equal to 2 times the allowable crosswind components. Okay, so usually the allowable crosswind components will be restricted to 25 kmph. So the width of the strip will be 2 into 25. The total width of the strip will be 50. So whichever the convenient scale you have, it can be the 50. 50 can be taken as 2.5 centimeters. So what scale you have chosen when we draw the Windrose diagram, it has to be converted to this suitable scale, and then choose what should be the width of the rectangular transparent strip. The next is what we have to do is you choose any one direction. Okay, first let us see, I'm considering the north-south direction. Now the rectangular strip has to be fixed in along this direction. So how to fix? You mark a center line on the transparent strip. So make sure that now the center line of the transparent strip will coincides with the north-south direction line. Okay, so this is how we have to place the transparent strip. So now what we have to do is we have to find out what is the wind coverage in this direction. To determine the wind coverage, so you can see here inside the transparent strip, some of the values are visible to you. Clear? So now add all the values which are visible inside the window transparent strip. So what is these values which are you can see? So these values indicates the duration of the wind. So when I add all these values, I get the what is the total wind coverage when the runway is oriented in the north-south direction. So when I add all these value, so I have got the along the north-south direction. So now the total wind coverage is 83.9 what we have got. So for example, I mean to say that along the within these value, the total value what we have got is 83.9 percentage, which are visible inside the transparent strip. For that, we will add the calm period. We will have the total wind coverage in the north-south direction. So that value we have got it as 97.4 percentage. So this is acceptable. Locating the runway along the north-south direction is acceptable since the wind coverage is more than 95%. But we should not stop here at this point. We have to similarly check along the all the direction, and respective wind duration or wind coverage has to be determined. So maybe in some other direction we can get still the better coverage, maybe 100% also we can achieve, or if not near to the 100% can be achieved. So we have to check along the each and direction for the total wind coverage. So once the north-south direction is done, now place the transparent strip along the north-northeast and along the south-southwest direction. So in this direction, check the wind coverage. Wind coverage, the total wind coverage will be with inside the transparent strip is 81.2 percentage, calm period is 13 percentage, total is 94.7. So it is not acceptable since it is less than 95 percentage of the wind coverage. So likewise, if I check for the other direction, that is west northwest and east southwest, the total wind coverage we can get is 82.2 percentage. Once again, it is less than 95 percentage, not desirable. So likewise, we have to check in the all the direction, and we have to choose the runway orientation is in that particular direction where we can have the maximum wind coverage. So now to summarize the Windrose diagram of type 2, so first what we require a wind data. So once the wind data is ready with you, you have to make a Windrose diagram. So in that, enter the data into the concentric circles for the chosen scale. Okay, draw the radial lines, concentric circle, and write the duration of the wind within the each and every sector. So next we have to choose a transparent strip, okay, where the length of the transparent strip will be greater than the Windrose diagram we have considered, and width should be twice the allowable crosswind component. And then place the transparent strip along each and every direction, check for the wind coverage. So those direction where the wind coverage is less than 95%, that is not desirable. Consider those direction where the wind coverage is greater than 95%, and in which direction we get the maximum wind coverage, that direction will be best suited for locating the runway. In the next class, we will determine how the runway, so now we have ready with the orientation, in which direction runway has to be designed. The next is we'll discuss how the runway length can be fixed up. Thank you.